My name is Brianna Swan, and I'm with my colleagues Mariana, Luis, and Sakib, and we're the Subarctic monkeys. And our project was real-time data collection framework in a virtual reality environment. So Mariana and I focused mainly on the data, the database, and the VR aspect. And Sakib and Luis handled sensors as well as creating some of the demonstrations. So today we're going to walk you through our project, our framework, and then we will present to you 2 video recorded demonstrations as well as a live demonstration. So virtual reality. Virtual reality is increasingly popular in the public and private sectors. It's sort of a buzzword these days. It provides collaboration, personalized environments where the user can experience a co-presence, even though they may be, experiencing something that's not actually there, or in an environment that is far away but feels close. It can take contextualized physical and physiological data from a variety of sources, and we want to incorporate this data to improve the experience. Therefore, there is a need for a VR framework that brings together all of the different sources. And our challenge is to create a solution to collect and integrate such data for collaboration and co-presence with a focus on medical applications. So we collect sample data and make standardized data cleanup for analysis. We take a VR scene, which is an application from the Microsoft Store called BasketBin. It involves physical activity and is used to trigger heart rate sensors, which we have here. Ideally, you can apply additional sensors in the future, such as tracking respiration, skin response, EEG, etc., especially when used in a professional medical setting. And for our project, we used the MongoDB Atlas free cloud database. So the requirements that we took on was real-time data collection. So if you recall from yesterday, we had a challenge that we were not able to get the data in real time. However, we resolved that by having a script written to connect the serial port of the Arduino to a PC in order to get the data in real time, which we will show you in our demonstration. We utilized the virtual reality environment that took in some different contextual data from multiple sources, and we'll go into the data a little bit later.
All right. So I will talk about the system architecture. So this is the proposed framework that we have for the problem statement that we're given. First, we have a user with an activity, of course, with the HoloLens. So this user will be equipped with the ECG sensors and, of course, the sensor from the HoloLens. So for the ECG sensor, it was mounted on the HoloLens EKG EMG tube, which was used to gather data, and then mounted it on Arduino Uno so that we can connect it to the computer. So the Arduino Uno sends the serial data to the computer, and then from the computer we wrote a script that sends the data to MongoDB in real time. So this is just framework that's developed for data collection. So for other cases, instead of HoloLens EKG EMG chip, this could be any other sensors that is connected to the computer. So that sends our data to the MongoDB, to the database in real time. Okay. So we are talking about the possible extensions of the framework that we have provided. So for any data that we have in the MongoDB, this could be used for further data analysis if that's the use case, and it can also be used for expert systems by possibly those in medical domains or other medical experts. So the data that we collected for now is from 2 sources. One is the eye tracking from the HoloLens 2, and the second one is the heart rate, possibly the pulse from the ECG and the EKG sensors. So the format of data that we collected for eye tracking HoloLens is we have the time span, we have XYZ gaze, because if you are using virtual reality, mostly it's usually in 3D, X, Y, and Z dimension, and then the target XYZ. Then for the R trace, we have the timestamp and the peak value of the ECG and EKG. Okay. So this is how this is the format of the ID that are collected. For example, we have the X elements, we have the target, we have the Y value and Z. This is just an example from how the data of the ID are collected. So basically, for the art data, we use an electrical. This is how it looks like when you read what's it called, pulse. So this is how it looks like. So just the challenge that we have was how to convert this kind of data to what's it called, a real value that can be measured. So with the help of Pi serial, which is Python library, we were able to serialize this data to a real value. So,
so if someone were to basically take all of our code, our package, and our sensors, in order to, we created a module called Subarctic. So all a user has to do is create a MongoDB account and create a database and retrieve the connection URI. And they don't need to know really any programming to use this library, or at least not complex programming. With our module, we created a variety of functions that enables a user to create a collection, delete a collection, insert data into a collection, and do a few other things. All the user needs to do is write a very simple Python script importing Subarctic into their script and saying, I want to create a new collection like this, and just pass a couple of variables into it. It's very simple. By doing it this way, it's standardized and it's very low processing power.
So after developing the solution, we try to propose the business case, the business potential of our solution. As my previous speaker said, our solution is simple, standardized, and lightweight. So that helps us with this type of medical training, treatment of patients, physical therapy, rehabilitation. And as you can see, the VR and AR market is growing, and at 2022, it's estimated to be $209 billion alone. But our solution will not be that expensive. The current solutions that you have in the market, it costs you from $100,000 to more. But the solution we have here, you need a HoloLens, the sensors, and the apps that we have is already free on the marketplace. So within like a couple of $1,000s, you can make this solution workable. And it's very simple to deploy. You don't need a lot of IT infrastructure as well. So our initial goal is to start with the Scalipsio community medicals, Understop, and other small clinics that you have. So you can focus on the pain rehabilitation or other small scales at first, initially, that needs 2, 3, 4 sensors to help the patients. Then we have a small dedicated IT integrated service. So this service, what it does is just to set up this whole thing. It's not too much, so it's a small thing will be enough. Then we have designed the whole integrated practical units. And our cost will be initially just the cost of the sensors, the HoloLens, and small, if you want to design a new models based on the customer patient requirement, then we'll have some initial cost. And finally, what we're trying to do is actually have a health outcome that will actually matter to the patient. The patient will get benefit, and especially the doctors. They'll be able to better understand how the patient, the feedback of the patient treatment. Because nowadays, if you are handling with, let's say, pain rehabilitation, you have to take the feedback from the patient to understand how it works. And this is the projected healthcare growth in VR, because the whole VR market is growing a lot. So as you can see that in 2025, it's estimated that the 40% revenue will be from consumer driven and 60% will be from enterprise driven. And this is the estimate from 2017 to 2025. So as you can see, the overall revenue in billions is growing more than 5, and this is also generated by developed by regions. So what is our future plan? So first, the solution we have is simple, it works, it's efficient, it's cheap, but we need to improve it more with data analysis so that we can have a better understanding how the data works and for different patients. And we have to include more sensors depending on what type of treatment we are working with. And finally, we'll deploy the whole system as a one unit so that you don't have to separately carry around everything. And we also have to define our own VR scenes. Right now, the VR scenes we are using is from Microsoft Store. So even though it's free now, but it might not be suitable for our case. Sometimes different doctors might need different scenarios. So that's our whole future plan. And now, Mariana will show us a demo.
Yeah, so now we'll present a little demo. First we will show a couple of videos of how the system works, what is the scene that we are going to see in VR, and how that looks like. So first, we have this video that shows the application that it's now that we now have on the VR. It's a small app that allows you to throw paper into a basket bin. So that is what it looks like. So you can start a game. And you first have to scan the whole scene so that the VR sets up the obstacles and stuff, and then it produces a bin that is placed in a random location, and then with some gestures you have to throw some paper. I think that is the expectation. Yeah, like that. And we chose this scene because the goal was to measure pulse, and we thought that this scene was a little active, so interactive, you have to throw, and that might increase your heart rate. And the other video is a video we took upstairs. It shows Candy Crush app, but yeah, it's just to show that there are some apps that are now in 3D and like involve you in the full environment. Some apps are just like desktop app that's shown in the VR, where you can play with gesture like it was a tablet.
Sorry, the participants is not pro, so that's why it's having a problem.
Yeah, and now we're going to show a live demo. So what we are going to do is I'm going to wear the VR and the sensor, and in real time we are going to collect data and then display data on the ground. So, what I'm doing now is entering stock. So let's go to access the VR.
Yeah, so this graph is representative of the values of the pulse rate, pulse data coming in from the sensors on Mariana. So the more she moves around, kind of the more variability we might see. And it's, as you can see, it's updating in real time. As soon as they'll print it.
So I should perform some basketball. Throwing paper in a bit. Yeah. So as we're not like medical experts, we really don't know how to interpret.
So basically, it's just the pulse rate is not about the participant. It's been done in real time, and at the same time, it's saving to the MongoDB.
But the potential is that
Yeah.
the potential is that we could integrate any sensor and like anything that some doctor might require to measure you. So to simulate like I don't know your body under certain conditions.
But you can see, like, it's this data is written to the database. This is our database. Here's those values that you see in the graph.
Right? Thank you.
Yeah, like you said,
Yes, that's the final goal, basically. The goal is that once we have the data, the medical analysis can be taken and, of course, use it for the analysis. We are not just experts. We can't analyze it for now.
Yeah, it was just more focused on the system itself.
It also set up is really cheap to implement, so we don't need to buy a lot of stuff. Just a price of that's how
I also like that you worked on your business case.
yes, I think that I also get.
So, thank you very much.
Thank you.